Alright, so let's try another one. The weight of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Alright, so right away they're giving it to us. It's saying it's proportional. The moment I see that, I know my equation is going to look something like this. Y equals m times x. They've even given us our variables. So they're saying if you know the weight of the object on Earth, that's your independent variable because they've assigned it x, it'll tell us the weight of the object on Titan, one of Saturn's moons. Okay? Alright, so what we need is m. We need that constant of proportionality. Alright, so let's plug in what we've got. An object that weighs 105 pounds on Earth would go in for x times m, and it would turn out that it would weigh 15 pounds on Titan. So, to solve for m, I divide by 105. Divide by 105. These cancel. So the constant of proportionality in this situation, if I reduce this fraction, is going to be, let's see, 3 over 21, which reduces down to 1/7. So our constant proportionality is 1/7, or in other words, what it's saying is, if I take an object from Earth to Titan, it now weighs 1/7 the weight that it used to. Alright, so if I go back to my direct variation equation model, it would be this. Y, the weight on Titan, is equal to 1/7 of the weight on Earth, which is x. Okay, and this would be our equation that I could then calculate whatever weights I needed if I had some, big NASA project and we're trying to get something on Titan. Alright, let's take a look at one last problem. Let's say we're talking about the graph and an equation, and we're comparing the two. So here's what we got. The distance y in meters that a 4-person ski lift travels in x seconds is represented by this equation. So in this case, they've given us the equation. X is the number of seconds that we've been on the ski lift. The constant of proportionality is 2.5, and it spits out y, which tells us how far we've gone in meters based on the number of seconds. Now the graph shows a different thing. It shows a 2-person lift as opposed to a 4-person lift. Alright, and we want to see, in this case, and the question's missing here, you should probably write it in, but the question that we're asking is, which of these is the faster lift? Okay, so the number of people we actually don't care about. What we care about is which one's the faster ski lift. Is it the 4-person ski lift or the 2-person ski lift? Alright. Okay, well, turns out that all we have to do is, again, look at our constant of proportionality. Now in this case right here, this 2.5, that's for our 4-person lift. And what that's saying is it travels 2.5 meters for each second it's been traveling, because x is the number of seconds. So if I say, okay, it's been 1 second, 1 second times 2.5 gives us 2.5 meters. So I travel, excuse me, 2.5 meters per second. Now, where do I find that information if it's graphed and not given to us? Well, once again, this goes back to our definition. Whoops, too far. Right here. Okay, that constant of proportionality, m, when it's in a word problem, is also the slope, m, when we're talking about a graph. So if you take a look here, our graph, let's say I go from this point to this point, has a slope of, let's see, this graph goes by 2's on this axis. So 2, 4, 6, 8. 8 meters for every 1, 2, 3, 4 seconds. So 8 meters in 4 seconds, which reduces down, divide by 4, 2 meters per second. Alright, so here we're just seeing that connection that the constant of proportionality in an equation is the same thing as a slope in a graph. Alright, so which one's the faster ski lift? 2 meters per second, in this case 2.5 meters per second, so it must be the 4-person ski lift. Alright, so you can see how slope directly ties into this lesson, how slope is the constant of proportionality, and how anytime we've got a proportional relationship, that we can always represent it by this equation, y equals m times x, okay, which is called the direct variation equation. All right, so this is what you're going to work on and become an expert at, is these proportional direct variation problems.